This is a model of the silver nitrate and copper reaction. Over here we have solid atoms of copper. You'll notice that they have a charge of 0 because they're in their elemental state. Over here, this is representing our solution phase. We have silver ions and nitrate ions, and they're apart from each other because they're dissociated. The space in between them all, between the particles is representing the aqueous, or rather the water that's present in between each of the silver and nitrate particles. As the reaction proceeds, silver ions will encounter a copper atom, and what they will do is exchange electrons. It turns out that two silver ions will each get an electron from a copper atom. That transfer of the negatively charged electrons will change this silver plus to silver 0. And we know silver 0, elemental silver, is like solid silver, like, we used to use for silverware. At the same time, that will change the copper to copper 2 plus because it's lost 2 electrons. Copper 2 plus ions, we've seen this in the lab a number of times, are generally soluble and they are usually blue in solution. So this is going to float out into the solution, and this solid silver is going to glom onto the copper metal. So then as the reaction proceeds, this just repeats over and over. A pair of silver ions will encounter a copper atom. They will exchange electrons, one electron from copper, a second electron from copper to silver, changing the copper to 2 plus, which will float out into the solution, and changing the silver to 0, which will become part of the solid. Notice that we didn't have enough silver to use up all of our copper, so we have some solid copper remaining. But visibly, we would expect to see the formation of some shiny silver metal, and we would expect the solution to turn blue. Notice that the nitrates have not changed at all in this process, and that is the reason that we refer to them as spectators.